Welcome to You Can Do It. Today we're working on the compressor. I've done a video before on how to pressure test a compressor to make sure that the cylinder's safe. This has been sitting around for a bit and I actually need a compressor now, so I've got to build this back up. Now, over here in Europe, a lot of houses have three-phase supplies, so this is actually a three-phase compressor, but unfortunately where I am, I actually only have 240 volt single phase. So this video is going to be how we are going to put a three-phase motor running with a variable frequency drive. I mean, I looked at taking out the three-phase motor, putting a single phase, but the single-phase motors are actually quite expensive at the moment. So it was cheaper actually to get a variable frequency drive, and plus I don't then have to get rid of the other motor, and I can, if I need to, I can switch it back again. So two parts to this really. One is the variable frequency drive, and then two is how we're going to set up the variable frequency drive. So for those of you who don't know, once you've got a three-phase motor here, look, you can see that it says there 230 or 400. So this can basically either run on three-phase 230 volt or three-phase 400 at 50 hertz. And you can see the amperage. So obviously if it's running on 230 volts, it's going to draw more current, 11. If it's running on the 400 volts, it only drives up basically just half the current. So it's a 2.2 kilowatt motor, 2,950 I think. So that's all we really need to know. So once you see that, you know that you can run it either three-phase 230, three-phase 400. So we're going to go, part of this within the video, we're going to look at how we change it from the 230 to the 400 or the 400 to the 230. And how then we wire up a variable frequency drive. Okay, now the first thing before, I'm building this up, so I actually haven't got the pressure switch on here and everything. That will all be included in this video. So what we need to do now is look at some way that we can mount the variable frequency drive. So what I was looking at, I was thinking maybe I could bolt it here. This is a bit too plastic and flimsy. So what I decided to use was these two bolts here and there on the other side. And what I'm going to do is just find some, I've got some stainless steel and I'm going to bend up some brackets. So let me go away and do that. I'll be back in a second. All right, back. That's what I knocked up. Basically stainless steel, so it's a bracket. I had to cut a little bit of a notch in there. So the idea is that's going to fit over there, bolt on there and there. And these holes here will be for securing the variable frequency drive. So let me screw these onto here, and then we'll go and have a look at what drive we've got, and we'll go through the whole setup of that. All right, so we've screwed those on tight. Look, makes quite a nice little support there. It's just above that, so it's not going to rub on it. We've done that. So now it's just a case of bolting that on there. And I'm trying to decide whether to do this way around or that way around, because the cables will come out one way or the other way. So I'll look at that and do that in a second. Okay, so we're back inside. So I've ordered a variable frequency drive off of the internet. So this is the model. And basically these are under, it's the same thing under lots of different names. I'm sure they just constantly make up a new name. But the one you want is the AT1 model, basically. Model AT1 2200, which is generally for a 2.2 yellow capacity is 2.2 kilowatts. You want to make sure. I mean, I've yet to go inside this and have a good look, but I reckon they're probably all the same. They just put a different sticker on it. But let's see, that's another thing. So you get the one that's got the right sort of power for your motor. Now there's lots of different, there's 4 models, an AT1, 2, 3 and 4. And they're all to do with, it's converting watt to watt. So the AT1 converts from single phase 240 volts to three-phase 230 volts. Obviously check when you're buying it that you are buying the right spec. But you might ask, why do you want a variable frequency drive if you're going to go from, say, 230 volts three-phase to 230 volts three-phase? And that's because you want that because this allows you all the flexibility to change the frequency, which in effect change the speeds of the motor, and you can have a soft start up, so it starts up softly if you're running a lathe or things like that. But we're looking at a compressor. Now compressors are really difficult, and if you look out, I couldn't find anything very suitable out there on the internet, which is why I'm making this video. The problem with a compressor is it needs a lot of power to start up when it's fully pressurized, and you're trying to it's then got to kick in. It's under load straight away, so it's got to start under high load. Now, another problem that you're going to have with these variable frequency drives is people say, well, you know, you've got your single phase in, your 3-phase out, and you just wire it straight up to the switch that's already on the compressor. Well, you can't really do that because you can overload the electronics inside, because this is basically a computer running the power. So what actually happens is you've got normal phases coming in, and then that's basically stripped back down to basically DC, and then convert it back from that into 3-phase. So you can just put some significant load on this if you just try and switch on the motor under load to start with, whereas if you let it run through the computer thing here, it should ramp it up slowly. So what I'm trying to say in a long-winded way is you can't just plug this into your switch. So what actually happens is you've got your single phase in, your 3-phase back out again, but the switch, the on-off switch, is actually an electronic switch, and that's a second set of cables which come into here. So I've got to actually try and find out where those are on the control panel. So the actual switch is just simply a continuity to the control board here, not continuity of the actual power in and out like a sort of traditional switch. So anyway, we'll get into that in a bit more detail. So this one didn't actually come with a manual or instructions, but I've actually already had one of these, which I've got on a pillar drill. So I took a copy of the instructions. So this is AT1, single phase to 3-phase, which is what we want. You can have single phase to single phase, which is AT2, 3-phase to 3-phase, which is AT3, and single phase to 3-phase, which is AT4. And I reckon the AT4 will be the higher 3-phase voltage of 380 probably. But anyway, these are the instructions here. So they go through all the different parameters you've got, and you actually have a lot of different parameters here. These are the terminals things, and this is what I'm going to have to get my head around, because I think some of these are going to be, I can use this as a switch for the actual pressure switch on the compressor. And these are all your different, when you can program it, you've got all the different parameters that you can set up. So there's a lot of information in here which I'm going to have to get my head around. Look at the instructions here. So coming from China, they're not exactly perfect. So actually this says for AT1 and AT4, but actually this is what we've got on the AT1 here. So you've got a ground, live, neutral, W, V, U. Okay, so you've got your mains, your single phase mains coming in. So you've got your live, which will be brown, and your neutral, which will be blue, and then you've got your ground or your earth, which will be yellow and green or whatever. Okay, so you connect your earth to that, live to that, neutral to that. That's your input. And then this is the output for your 3-phase motor, which is obviously W, V, and U. And you'll also have a ground for that, and that ground connects in there. So both your grounds connect into there. So your input from your single phase is there, and your output for 3-phase is there. So that's fairly simple there to wire that up. So we can go and wire that up. Now, as I said, I'll come back to this later once we've got that. Well, first of all, what we'll do is we'll wire this up like this, and we'll just test the motor out and test the compressor to make sure it all works. And once it works, then I'm gonna have to come back here and we'll work out how to make a on-off switch from using these terminals here somehow. But there's a lot of information now. When we set this up, we need to just check. These things come in the box from the factory, and this is what they're supposed to be set. So for instance, if you go to the program of P00, the maximum voltage is set at 220 or 380. They're saying the default is obviously 220 or 380 depending on what model you get. They're saying here that the frequency, so that's the program 01, is the frequency, which is between 0 and 400, and they're saying the default is set at 50. Yeah, and then this is the program part 2 is the intermediate voltage, and they're saying it's set at either 110 or 190 depending on which model you've got. Now it's worth going through and just checking some of these fundamental parameters, because even though you get it new out of the box, someone else might have had it and messed around with it or whatever, or it might not be set to the operating things that are actually specified here. So I can show you when we go back outside how to just quickly check some of those fundamental things. Okay, so what we're going to do now then, we're going to go back, we're going to wire up like that, and we're just going to check a few of these things that are set right, and then we're going to just do a test to check that the VFD will actually run the motor and it all works fine, and then we'll come back and try and set the switch. So here we are at the machine. So look, if you look down here, program 01 is the reference frequency. So if we go here, program, it's flashing here on the video, but it's not actually in real life. So program 1, and you push the up and down arrow. So if we go 1, that means we program 1. So if we press function data, we can see what that's set at. That's set at 50. So the maximum reference frequency is 50. Now if you wanted to turn that up, you can just go up, look, like that, and you can set it higher or lower. I'm just going to leave it at frequency 50. There we are, 50. So then function data is end. Yeah. Now if you want to go up to the next program, so that's on 02. If I go to, let's have a look at, go down to 0, that's the maximum. That's showing you the maximum voltage, which is there saying 220. So if you want to go up with that, no, you can't. You can't go any further than 220 on this. You can go lower if you want to. So this model, the 81, is maximum of 220 output voltage. Function there. You've end. If you want to finish it, you just press program, and then you're back to the norm. You're back to start. Okay, so that's it. So we can just go through there and just check against some of these standard parameters and make sure it's all set, which it does look like it is. Okay, we're back out here with the compressor. So what we'll do is we'll just undo the little screws here which hold the cap on here. And we'll get to the terminals. Now obviously I've already undone the power cable because as you can see it's not connected, because when I strip it all down. Okay, that comes off now. I've undone that. Let me put that up there for a second. Right, you can see straight away this is wired up for star. So these are your three phases here, and they're all linked together. So that's always a star connection set up. And then this is your input side. 1, 2, 3. Now to change this from star configuration to delta, what we do is we have to undo these sides here, take these little bands off, and then we connect them this way. Okay, so what I'm going to do now is I'm just going to undo these screws, these 3 screws here, and we can take these bands off. So let me do that. Okay, so we've got this now. So now we're going to put this into delta format. Okay, so in delta format you're strapping across here, here, here. Now be careful, because we're not actually, we've got to make sure we get the right terminals on this side. Yeah. So what we'll do is, to start with, we'll just put these straps over. 1. 2, 3, or 2. There we are. So there's your they're the 3 straps over, and we can put these on here. 1, 2, 3. Right. Now don't just connect these up like that, because that's not the correct way. What we have to actually do on a delta is we go like this: W2 to U1. U2 to V1, V2 to W1. So just for example, W1, and this is the other side of it. Now if you just connect those 2 up like that, obviously you're just basically shorting out that circuit, so that's not going to work, is it? So you'd be connecting, if you just did that, you'd be connecting W2 to W1. You need to do W2 to U1. Okay? If you look down there on the block there, it says, you know, you've got VW or U or UV, it doesn't really matter, just read what it says on the block, and then you just got to make sure you've got the colour, so you'll know that what the other side will be, and then you can do it across. So sounds a bit complicated, but let me just do this and then I'll talk you through it. Okay, so this is W, this is V, and this is U. That's just as marked on that block there, right? W, V, and U. Okay, so looking at that diagram there, the W is the red cable in, all right? That's W1, and obviously the one that comes out is W2, right? So if you look at that diagram there, you just stick that like that. Oh, well, so you can actually see that. You can see that W1 goes to V1, so therefore that was W. And you know on this diagram, oh, this is V. And V is black, so therefore W1 goes to V2, so that's the black, V2. Yep. On this one you've got V1, which is obviously black, goes to U2. Now you know U is actually blue, so that's why it goes to the blue wire. And then the final one is U1, which we know is blue, was going to go to W2. Well, we know W is the red, so therefore W2, you want to put the red there. Right, that's great. So that's all wired up and across there. Now we need to put the power in. Now, again, it doesn't really matter which cables you've used. If you look on the back of here, you've got W, V, and U. So the way I've wired that up, W is blue. Yeah. So therefore, this is the W terminal. So that goes on there. That's W. On there, you've got V is brown. Yeah, that can't come off. And then we know that U, according to that, is black. So that's good to go. Right, so I'm just going to tighten all these up. Yep, and I'll be back in a minute. Right, that's there all nice and tight. So now I'm going to put that back into there and put the lid back on there nice and tight. So just double check that you've got it all correct, which I have done. And then I'll put the lid back on. Okay, so I've mounted that up all on there nice and tight. You've got your cables in, your power in, sorry, and your power out to the motor, which we've sort of just done. And you make sure your earths are there. I've checked that. We put a lead on it. Okay. Now I have just chucked that back on with a feed in here because I just want to check that the pressure switch works. But now what we've got to do is work out what the switch is. So first of all, I just want to check that the motor runs, and then we'll look at that switch, because obviously if we just let it run like now, it'll just go until the pressure valve goes, or it just blows, it gets ridiculously high. So let me just plug it in and see how it goes. That's interesting. It's not actually flashing in real life, but when you look at it on the video here, it's obviously, it looks like it's flashing, but it's not. So it's saying that that's the frequency. Now I set a maximum, I think, yeah, maximum frequency of 55, but if we just run it at 50, yeah, right. So then to start it, we just press run. Now obviously this is a standard spec, the standard spec of the VFD, which we can change the parameters in there if we want to, but let's just run it as standard. There we are, look. There you are, you hear that? That's a 3-phase motor running on a single phase. We've got a single phase in through the VFD, producing 3-phase for the motor. So my wife is working at the moment, so I don't want to make too much noise, but it runs. Look, do it again. Now what you should notice immediately is that it's got a much smoother run up than a normal compressor, because normally when you start the compressor, it's like a massive draw of current and a massive start, because it's obviously got to be able to overcome the pressure when this is already pre-pressurized. It's not pressurized at the moment, but if you can already feel that it's got a much smoother, a softer run up, which is one of the great things about having the VFD, is that you'll just get you can have a sort of slower ramp up and ramp down. So it just makes things a little bit quieter on the startup, but also less current pull and everything. So it's good. So now what we're going to do is take out, I've got to have a look at those inputs in there to try and work out how to get the switch here. I've obviously taken all the cables out of there. So now we're going to use that as just a simple continuity switch. So it'll be either it's continuity or not. And I think there's a way I can wire it up into here, and that switch will then switch off the compressor when it gets to the desired pressure. I've been through that already on the video, why we can't wire that up straight to there, because you can overload your VFD. So it's looking positive now. So I'm quite pleased about that. So let me go and do some paperwork, do some reading, and I'll come back and tell us what we're going to do in here. In fact, what I'll do is I'll just take that off now. So here, look, here are all the little terminals here. So I just got to read up what each one does, and there's a COM. So I think just off the top of my head, it's going to be from a COM, which is sort of ground, to one of these terminals here, and that'll be a switch for on-off. So I just got to have a look at the paperwork and see which one that is. Okay, back inside again. If you look at these diagrams here, you can see here it's saying that X1, 2, 3, 4, 5, 6 are all like inputs, and they just basically short out between whichever port it is and the COM. So there's just, you see a little diagram there with the switch. So you basically just say you put a switch between X1 and COM. So if you go over here, start looking down here, it says here, these are your ports, right? So they're already pre-programmed when you receive it. So X1 is programmed for speed 1, speed 2, X2 is speed 2, X3 is speed 3. So they're different speeds, right? So what that'll actually do is change the frequency, all right? And so what you do, what it's saying is, if you short X1 and COM, you'll get an input signal which will give you speed 1. If you short X2 and COM, you'll get a signal which will give you speed 2, and X3 and COM, you'll get speed 3. So that's just like if you wanted to have a switch that gives you different speeds of the motor, which will be running different frequencies. Basically, instead of you twisting the frequency handle knob yourself, it's just does that automatically. So you can set them up. And then here it says X4 input forward rotation control switch, which I presume is a switching on and off. And that says you short X4 and COM. So you just put a cable between X4 and COM, and that is the input signal to start it. Now, I racked my brains on this one. I thought, well, I can't work out how just shorting that X4 and the COM will actually start the thing up, on the basis at the moment you have to push the button. So I don't see how that would override it. So I started doing a bit more reading and scratching around, and funny enough, and this is very important, that if you look down here, you get down here to number 11, P11, says start stop control source, and it says here, as a default setting, when we get it, it's set at 0, which means the panel keyboard. So what that's actually saying is the only way to start and stop the machine is with the panel keyboard. All right, well, that means that you can basically do what you want with sorry guys, you can do what you want with these things here. It won't make an effect. Well, no, it won't make an effect with regards to starting and stopping the machine, because at the moment it's saying only listen to the panel keyboard. So you've got another option of programming P11 to 1, and that's the RS485 connection, or you can program it to 2, which is the external port. So what I'm imagining is if I change the P11 program to 2, that will then basically tell the computer to start listening to these inputs here for a control of starting the motor. And because they've already, I think, preset X4 to that setting, I'll use X4. And what I did actually, I found here, yeah, if you go here to P50, that is this is a program 50 on the controller, is talking about the X1. X1. Yeah, excuse me guys, this is not the easiest thing in the world. So that's X1 down here. So I presume if that's P50, I reckon that's P51, P52 and P53. So X4 is probably P53. And if we go down here, P50, yeah, P50, P51 is 2, P52 is 3, yeah, P53 is 4. Yeah, so input 4, which basically means X4, is one that we're going to use. I mean, you could use any of these, and then it's what it's telling you here, look, from here, it's telling you what each of these X's, X1 to 6, you can program for a different outcome. So if you do it as a 1, that's a wire control stop. In other words, if that would just stop it. That's a key stop, keying operation, stop keying. If you go down here, look, number 5 is a wire forward operation. So that presumably means you've got a wired switch and it tells it to do a forward operation. If you put it to 6, it would do a wired operation but a reverse. Okay. Now if you look down at P53, what they've already set it at as standard, this is the default, is 5. So they've set it to 5, which is wire forward operation. So yeah, so that's why. I hope you're with me with this. It's really simple. That's telling me then that X4 is already set to function 5, which means it will be a switch to start the motor. So what we can do when we go back outside is we can check that program 53 here, program 53 is set to 5, which is to switch, which is a forward switch on and off. And I must make sure that program 11 here is changed from 0 to 2. So what that'll do is turn off the panel keyboard from a point of view of stop start and put it down to the external port, which is number 2. That's really important. So let's go outside and do that. Okay, we're outside again. Okay, so now what we need to do, remember on here, we need to make sure that we get number 11, the stop-start control source. At the moment will probably be on a panel keyboard, and we're going to turn it to the external port. All right, so if you just check that now, if I press, so it starts, look. Okay, so now we'll press program. So on 0 we need number 11, push that to 11. Function data will give me what that setting is at the moment. Look, and you can see it's 0. And 0 on there is the panel keyboard. So that means that you control the start stop with the panel keyboard. But if I move that up to option 1, option 2, so we move it to option 2 there, which means external port. So if I then press function, that's ended. Yeah. And now. Right, so that's set up. So now look, pushing these don't do anything because it's waiting for a signal through into these ports here. Okay. Now the other one we need to check, if we go program again, was number. Here we are. We were going to use port 4, which is number 53, and we need to make sure that that is set for wire forward operation. Okay. So let's go to number 53. I think if I hold that, it'll suddenly go fast. Yeah, it's going really fast now. (53) function data. Yeah, and that's set at number 5. So that's already preset at that there number 5. If you wanted to change it to something else, like reverse or something, you can do all that. But that's for another video about the full options with these VFDs. Okay, so we press that function, that's in there and set, and then let's go to program, it's back to normal. So look, this won't work, so it's waiting for feeds into there. So now what we'll do is take this off, and then we'll start wiring up this here. Okay, so what I'm doing here, I've got my normal switch. Now normally you've got your actual main power coming in and out. Because we're using the variable frequency drive, we just need basically a continuity switch, which is just basically in and out. There's no actual sort of power going in, it's just a continuity switch. So it doesn't need to be thick cable or anything like that. So I'm just going to use that in one side and that in the other. The bit of thing I could find at the moment, I'll find a suitable black colour later, and then I'll cut this off here, and then we'll feed this into here. So let me just connect these two up on either side, and then I'll just check on the continuity, and I can put that back. Okay, so I've wired that in there, and this comes up here. As I said, I'm going to get a nice black cable later, but I'm just going to test this out. And I just want to make sure I've got continuity between this and this, because the way this switch works is that it's closed, so the switch it's on basically until it gets to the right pressure, and then it'll cut off. And then once it drops down, then it'll switch back on again. So it should be continuity. For those of you who don't know, the continuity is that one there with the little sort of speaker sound there. So if you turn your gauge around to there, yeah, touching these two cables together, look. So when they make the noise, it knows you've got continuity. Okay, look, I just wrapped the cables out. Can you hear that noise? So I've got continuity, so the switch is working. Well, at least it's working to keep it running. Let's just see, we'll have to do a check to make sure it turns it off. I've just put that cover on there. So this has got like that's a off, and that's an auto. So we'll keep that on auto. Right, so now here we're going to use X4, and we need to connect it between ground or common and X4. So let me do that now. Okay, so that's in X4 and common. All right, X4 and common. Let's try it out then. So we've got the thing plugged in. She's plugged in there. Look, I've got the power on here now. Of course, it's not flickering in real life, but it's because of the video. But that's at a frequency of 50. That's what it's set at. So she's on now. Normally, as soon as you turn this on and you press run, it would kick in. But look, I'm pressing run. It's not doing anything because we've turned off the panel from a point of view of controlling the stop start. That is all now done from this control switch here. Yeah, so that's what controls the start and the stop of this machine. So at the moment, let's test this out. So I've had it running, and it's pressurized that up to over 6 bar, and it's cut off. So what I'm going to do now is I'm going to get my little thing here, drop the pressure, and we'll see if it kicks in. If it gets under 5 bar, switch will kick in. Now, kicks in, look. And we can spark it up. Yeah. So this is now running because of that switch there. It's went into this control board here and then moved it. So now, this should turn itself off when it gets up to 3 sets. It turns off at about 8 bar. So they are. So that switch cut, which basically cut the continuity here, which means there's no continuity up here, which has cut that, so it's turned the machine off. So I am quite pleased to say that we've now got a fully functioning 3-phase compressor working off a variable frequency drive with the switch there controlling the actual unit as a input and output source switch, rather than actually breaking the power in and out. So yeah, that's it. We've done it. We've got a compressor. I hope this has helped, because I can't find anything out there on the internet that actually explains everything, you know, step by step. So if you like the channel, subscribe. Please send me a comment. I'll see if I can help you. And just remember, you can do it.